This field represents a size of about 24 football fields. The average farm field on the Eastern Shore is 217 football fields. However, it's estimated that 358 football fields of farmland is converted to wetlands annually on the Eastern Shore. So that means 1.5 farm fields are removed from production every year on the Eastern Shore.
Just like the Got Milk commercials taught us when we were younger, that in order for us to be healthy adults, we depend on the experiences while we're young. That's exactly what the carryover effects hypothesis states, that those that experience less stress earlier on have the energy to continue the population forward, whereas those that experience more stress earlier on might not have energy necessarily to survive. So I'm really interested in understanding these carryover effects and how that affects the population of oysters. And in particular, this is important for future climate change studies because you can imagine that we use juvenile oysters from either of these populations, we conduct a study on them, we might get different results, and now we have an inconclusive understanding of what might happen to oysters in the future.
This management scenario could be a little off, right? So for example, if you focus on New Jersey, we know that New Jersey, based on the 2020 management scenario, they have to share 1% of the total cobia catch with 3 to 5 other states. But if 2012 is anything like, if 2020 is anything like 2012, maybe our management scenario should look more like this, where we allocate more cobia to states further north and maybe a little bit less cobia to states further south. We can even take this a step further and open and close fishing seasons during different months and in different states based on where we project for cobia to be. And with that, I want to leave you with one lasting remark, and it's that as fish adapt to climate change, I think it's important that we do.
We also need to consider a more holistic approach. Blue catfish isn't the only problem. We have issues of nutrient pollution, overharvest, and so blue catfish is one part of the puzzle, but it's not the entire problem. And I think that if we look at a larger scale and incorporate the stakeholders more, we can, and through messaging, we can have a better feel for how to influence people's economic, social, and cultural aspects of their lives. And thank you.
And I was drinking my coffee with my mom, just chatting about life, adjusting to being in Virginia, and the big question came up. What are you going to be studying for graduate school? And so me being super excited, turned to my mom and said, can you hear me? I'm going to be studying urea. And like everyone here, my mom just started laughing at me. And then she proceeded to completely horrify me by asking, honey, you're getting a degree in marine science. Why are you studying pee? Which I had to sit down and explain to her, actually, urea is a very important nutrient source. So if you get anything from my talk today, I hope it's that you appreciate the role urea plays in our coastal ecosystem.
So somehow I gave myself the job of trying to convince you at 9 a.m. that dirt is really important. And in particular that sand, more specific word for a type of dirt, is a vital resource. And how is it that something as tiny as a grain of sand can be considered this vital natural resource? Well, part of the reason is that sand stabilizes and protects the beaches that we care about. And those beaches have a tourism and recreation value. Sand is also used in concrete, so it's part of a multi-billion-dollar construction industry. And then sand often contains minerals, precious elements that are important and often lead to controversial mining operations of sand.
So why does this all matter? Fish have limited strategies to deal with cold. They can't just put on a sweater like we do. So, when we think about climate change, people tend to think about rising temperature and a warming ocean. What we think less about is there will be still extreme events like the winter extremely cold from time to time. And what I'm interested in is by studying populations in Virginia and North Carolina that has been routinely experiencing these extreme events and understanding their genetic makeups, we might have a better understanding of their resilience going into a more unpredictable future.
Close your eyes with me and envision the sea. You're on a boat far outside of the Chesapeake with only a thin, dark line marking the coast on the horizon. The waves are crashing. A lonesome gull calls out distantly. The blue-gray Atlantic stretches around you. In a major twist of events, Thor breaks through the sky and hurls you into Ant-Man's shrinking suit. Shocked, bewildered, and caught off balance, you fall into the ocean, shrinking as you go. You feel yourself getting smaller, smaller. In fact, you're only a millimeter in size and are floating along helplessly with all of the other plankton. Speaking of plankton, you feel a spiky nudge on your back. Whirling around, you see a strange creature, similar in size to you. It appears to be an armored mosquito. It has a spine protruding from the back of its head, a set of giant bulging eyes, a pair of smaller spines instead of ears, and a final spine replacing a nose. The oddity quickly propels itself backwards, away from you. It zooms directly into the path of a second armored mosquito, and a battle of miniature proportions is waged. You watch, horrified, as the second armored mosquito manages to tear the long abdomen from its opponent's head, quickly devouring any soft tissue it can grasp. Do I have your attention? What trauma in miniature did I just force you guys to endure? A fight of the fittest? Yes. Some sort of cannibalism? Yes. But what are the ramifications of that tiny struggle to the whole of the Chesapeake? You just witnessed the precursors of the delicious and economically valuable Atlantic blue crab duking it out in the open ocean, far from the bottom waters of our nearest estuary.
So it turns out, especially during the wet months and wet seasons, when there's a lot of freshwater flow and the salinity of the bay decreases, pretty much all of the sub-estuaries in the bay, but also most of the upper part of the bay actually becomes inhabitable by blue catfish. So the question at this point is not so much how far into the bay are they likely to come, because we feel like they are probably going to end up everywhere. The question now is, what can we do about it? How can we make the best out of this poor situation? And one of the answers is probably harvest. If you can't beat them, eat them.
So once we collect our corals from Virginia and from Rhode Island, we would bring them back to the lab and run them through our coral stress test. So instead of a stress test for humans, where you maybe run on a treadmill, you're hooked up to some wires, this is our coral treadmill. So we seal our corals inside these chambers, and we're measuring their metabolic rate across a wide range of temperatures. And the point here is to ask the question of whether coming from a warmer home or a colder home affects your metabolic response to extreme temperatures. And this gives us an idea of essentially the thermal range that these different populations can inhabit and thrive in.